Hello and welcome to another one of D's ADD videos. Today we're going to be looking at an example of a quadratic function using the epsilon delta definition. So let's come up with a function. Let's look at limit as x approaches, 2 of x squared minus 3x plus 5. Sounds good to me. So 4 minus 6 is negative 2 plus 5 is going to be 3. So the steps don't differ in any way. What we're going to do is first write down the definition of the limit. Ooh, that was a horrible epsilon. I think I'm going to rewrite that epsilon. At least it doesn't look like 3. Earlier on, my epsilons were looking like 3s. And then this is whenever this is true. So your C value in this case is 2. Always comes from right there. Alright, so if we plug in, we're going to have x squared minus 3x plus 5 minus 3. And our goal is to make that look like our friend x minus 2 over here. So what we do is we combine our like terms. In this case, only like terms are these numerical values. And we get x squared minus 3x plus 2. And we have to factor. If you remember your factoring skills, 2 times the 1 that's here, it gives me 2 factors of 2. That add up to a negative 3 would be negative. So this is factors of 2 that add up to a negative 3 would be a negative 1 and a negative 2. So you break this middle term over here into that negative to a negative 1. So yes, most of you should be able to factor this without doing by grouping, but just a quick refresher in case you forgot, factoring by grouping always works. Oops, that should be a 2 right there. That's sloppy. We don't like sloppy. Let's go ahead and erase that. Factor out the x. You get x minus 2. Factor out the negative 1. You get x minus 2. So whenever you factor out the x minus 2's, you get x minus 2 times x minus 1. So we did get the expression we wanted, but unfortunately we got an extra expression that we have to eliminate now. So the expression we wanted was this x minus 2 that's right here again. And we have that x minus 2 right here, so that means we need to come up with a numerical bound for this x minus 1 right there. And this is how you do that. You go off to the side, you start with your x minus c value. So this is x minus c was 2 and is less than delta, and you pick an arbitrary delta. 9 times out of 10, delta of 1 will work. And what you do, actually this x minus 2 is an absolute value sign, so forget that. Plug in that 1, and then you solve and try to make up that x minus 1 expression that you want from what you have. So when you drop the absolute value signs, you have to write another inequality and put the negative of whatever value you have here. In this case it's a 1. And then you ask yourself, what do I add to this negative 2 to make it into a negative 1 that I have right there? Well, adding 1 to a negative 2 makes it a negative 1. So if I add 1 to everybody, then I can figure out what happens. So this side will become 0. This side will become x minus 1. This side will become 2. Alright? And what you do from there is you pick the largest absolute value, or the furthest away from 0, and you bound it by that. So in this case, between 2 and 0, 2 is further away from 0 than 0 is. I know this kind of sounds odd, but what you do here is you put a negative 2 so that you can have the same value on both sides, and then introduce an absolute value to bound that solution set. So for instance, this is just purely hypothetical. I'm going to write in a different color so you know it's hypothetical. Let's say that this number of 0 right here, let's say that that was a -4. If that was a -4, then you would have put a +4 on this side, and then this value right here would have been a 4. But it wasn't, so we're going to stick with that 2, just so that you know if you see something like that later on down the line. Here we can plug in the 2 in place of the x minus 1. We still have the x minus 2. It's less than epsilon. Divide both sides by that 2, and you get absolute value of x minus 2 is less than epsilon. And then by comparing it, without minimizing your entire work there, you would get that delta would be epsilon over 2. But since we picked a arbitrary value of 1 for delta earlier, to find that new delta, we have to use what's called the min function. And the min function, what its job is it'll pick the smaller of the two choices. So depending on what this epsilon right here, depending on what epsilon is, you end up with either 1 or epsilon over 2. So for instance, if epsilon was 4 over 2 is 2, and the minimum between 1 and 2 is 1. If the epsilon was 0.2, well, we would have a 0.1 here, and the minimum of the two values would be the 0.1. That's how the min function works. So basically, everything's the same until you get to this point here where you've bounded them both, and then you have 2 expressions now instead of 1 with variables, so you have to pick an arbitrary delta. 1 will work most of the time, and then you need to bound it. Again, the key for this bound is the furthest away from 0, and then plug that in to solve min function. I hope that clarified any doubts you might have over epsilon delta definition for quadratics. Make sure you check out any other videos that you need to check out to help clarify any doubts that you might have. Thank you, and have a nice day.